addition of vectors. We continue to look at that topic. Now, let's add two vectors, right? First of all, you might have an object here, and you have two vectors acting on it, all right? Or better yet, let's put the object over here. This is our object. Two forces are acting on the object. One force is pushing it this way, and the other force is pushing it in this direction. Now, you can tell that there will be some movement if it can move, but the equivalent force will be somewhere between this direction and this direction, somewhere over here. We can, of course, calculate the exact angle and magnitude of that force. All right? Now let us take two vectors, and we're going to add these two vectors. Let's look at the drawing of the vectors first of all. Let me put one vector here. It starts here and ends here. And the other vector now starts here and ends. Where do I want it to end now? So it ends here. Good. Now let's just erase what I had before. Now let's call this vector A and this vector B. And imagine that A is acting in this direction and B is acting in this direction. I want these vectors to be thicker than they are right now. So let's do that. Let me make this thicker. Good, that's vector A. And then vector B. Let me thicken vector B as well. Good. Now, here I have the vectors in such a way that the end of one touches the beginning of the other. So I'm going to need a third vector to close this triangle. Once I close this figure, I'll have the triangle, and what I'm applying is the triangle law of vectors. Let me set up the third vector, which is what we call the resultant. Let me make it this color and make it thick. Okay, nice. Now, what we have is a triangle where we have A, one vector, B, the other vector, and that's how you add the vector, making one end touch the beginning of the other, the end of one vector touch the beginning of the other vector. Then you close the triangle with the answer, which is called the resultant. Now notice, if you follow the arrows around the triangle, you go like this. However, the arrow on the resultant must not be that. You must turn this around the other way to oppose the other arrows and put two arrows on it. Now let's use matrices to add these. Vector A is the vector we want the horizontal and vertical components of A. Alright? Now, To get A, we would have to move 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4, 5 up. So the x value is 7 and the y value is 5. The horizontal component is 7, the vertical component is 5. What about B, the vector B? To get B, you have to move from below one end to the other. 1, 2, 3, 4. Alright, let's move this way. 1, 2, 3, 4 to the right, and 1, 2, 3, 4 down. So it's 4 to the right, 4 down. 4 to the right means x is 4. 4 down means the y is -4. The y component. X component is the horizontal, the y component is the vertical. Now adding them using matrices, let's say A plus B. Vector A plus vector B is going to be 7, 5 plus 4, -4. And that will be 7 plus 4, 5 plus -4, which is 5 minus 4. So 7 and 4 is 11, 5 minus 4 is 1. So the resultant is supposed to be 11, 1. Let's see if that is the case. For the resultant, we have to go to the right and then upwards. We have to go to the right and then upwards to move the equivalent from one end to the other. So instead of going straight across the vector, we could move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the right and 1 up. And you see it here. 11, positive 11 is the horizontal component. Positive 1 is the vertical component. So this implies that we moved 11 to the right, 11 units to the right, and then 1 unit upwards. So you see, we can actually add the vectors using drawing, as in this case, or using matrices, as in this case.